Okay, so now let me introduce the concept of limits involving infinity. And let's just start with the graph of 1 over x that we have here, which is f of x. And let's find the limit of 1 over x as x approaches 0 from the right here. So as we're approaching 0 from the right, let's start here at 1. This is probably half, quarter, and then we're getting very, very close to 0, but we can't actually approach it because remember, there's an asymptote right here at x equals 0. But as we get closer and closer and closer and closer to 0, this function just skyrockets upward, doesn't it? It goes straight up. And it's actually going to be infinity. So the limit as x approaches 0 from the right of 1 over x is infinity. I hope that everyone can visualize that and can see it graphically. If we want to plug in numbers for 1 over x, we can do that too. For example, as you get really, really, really close to 0, so let me pick a very small number, many zeros that's very close to 0. 1 over that would be, let me see how many, 1, 2, 3, 4, 5, 6, 7. So that would actually be 10 to the power of 7. So pretty big number, 10 million. Let's hope that I got that right. Did I? 1, 2, 3, 4, 5, 6, 7. That'll be embarrassing if I didn't. So the closer that we get to 0, adding more zeros before that 1 here, we're going to get closer and closer to infinity. So that's why the limit as x approaches 0 of 1 over x is just infinity. Now, what if we want to find the limit of 1 over x as x approaches 0 from the left? Now we're going from here downward. We're going straight down. Now that we're going down instead of up, guess what the limit's going to be? Negative infinity. I hope everyone can see that graphically. Okay, but now how about the limit of 1 over x as x approaches 0? No longer from just the right or just the left, just the straight limit as x approaches 0 of 1 over x. That would actually not exist. Does not exist. How come? Because the limit as x approaches 0 from the right and from the left, they're different. They're positive infinity and negative infinity. Therefore, the limit right there, the limit as x approaches 0 of 1 over x, doesn't exist. Okay, now let's move on to the limit of 1 over x as x approaches infinity. So now we're just going straight to the right forever that way. And as you can see, the values of y, they go straight down. And they get very, very, very close to 0. Even right here at 10 already. So as we approach, or as x approaches infinity, y will get very close to 0. This you can take as a given. I hope that everyone can see that, can visualize that, right? We're getting very, very close to 0 for y. Take it as a given. Limit as x approaches infinity of 1 over x is just 0. Okay, but now what if we're looking for the limit as x approaches negative infinity of 1 over x? We're going this way now. And as you can see, it's also approaching 0. So we're going that way. As we keep going this way, we're going to get closer and closer and closer to 0. And that's it. Now, just to wrap up our introduction, I want to figure this out though. What is the limit as x approaches infinity for this rational expression here? Sorry, I blanked out for a second. So 4x squared minus 2 over 3x squared plus 5x. Now let me just make some room. Deleted the graph. I'm not going to graph this. I'm not going to graph this rational expression. I'm just going to determine the limit algebraically. How can we do that? What I'm going to do is that I will multiply the top and the bottom, or the numerator and the denominator, by 1 over x squared. And why x squared? Because I'll look at the highest exponent here in the denominator. And this will make sense in 1 second, I promise. So we're going to get the limit as x approaches infinity. I can distribute the 1 over x squared both ways here. 4x squared times 1 over x squared is just 4, because the x squareds cancel out. Then we also have negative 2 times 1 over x squared. All over. I'm also distributing 1 over x squared this way. So we get 3x squared times 1 over x squared, which is again just 3, because the x squared and the x squared, they cancel out. 5x times 1 over x squared is just going to be 5 over x, because 5x over x squared, the x and the squared cancel out. Oh, they got messy. There we go. So 5 over x. Now here's the thing. Every time that we have anything similar to 1 over x, and we're looking for the limit as x approaches infinity for 1 over x, or maybe the limit as x approaches infinity for negative 2 over x squared, or anytime that we have a constant over values of x down at the bottom to any power, to any, let me rephrase that, to any positive power, we're going to end up with 0 as the limit of x approaching infinity. And I can actually break this limit down with the limit laws, or the rules of limit. So let's take a look at it this way. We're going to have limit as x approaches infinity of 4 minus 2 times the limit as x approaches infinity of 1 over x squared all over the limit as x approaches infinity. I know it gets a little bit tedious to draw the limit as x approaches infinity every time, several times over here, but we have to do it. So let me put the 5 outside right now, according to limit laws. Hope you haven't forgotten them. If you haven't checked them out yet, take a look at them on our website. And let's take a look at this. Limit of 4 as x approaches infinity, that's just going to be 4. 4 is a constant, right? So that's it. But now, the limit as x approaches infinity for 1 over x is just 0. So we have just negative 2 times 0. Down at the bottom, the limit as x approaches infinity for 3 is just 3. And the limit as x approaches infinity of 1 over x is just 0, like we already knew. So we have 5 times 0. So these guys cancel out, because negative 2 times 0 is 0, 5 times 0 is 0. So we end up with 4 over 3, and that is the limit as x approaches infinity of our rational expression right here. So now I'd suggest that you scroll down, try some questions on your own, and sorry for making this introductory video so long. Good luck.